Hello everyone, this is Amar Sonone. In this video, I'll be discussing about the types of stresses and strain in a body. So let's start. So first of all, what is mean by stress and strain? So let's see stress. So here in this animation you can see that body is subjected to some external force due to which there is deformation in this body. Now this body will try to oppose this deformation so that some internal resisting forces are developed in the body that will try to offer resistance to the applied force. So these internal resisting forces are equal but opposite in direction to these applied forces. So stress is nothing but internal resisting force developed in a body per unit cross-sectional area is called as stress. So this stress is denoted by letter sigma. So this sigma is equal to load applied per unit cross-sectional area of that body. So where load is given in Newton while cross-sectional area in mm. So Newton per meter square or Newton per mm square is a unit of stress. So there are three types of stresses: tensile stress, compressive stress and shear stress. So tensile stress and compressive stress is also called as normal stress. Now let's see what is meant by strain. So you can see that body is subjected to some external forces. So due to these external forces applied on this body, there is deformation of this body. That means there is changes in dimensions of this body. So the ratio of change in dimension to original dimension is called as strain. So the ratio of change in dimension to the original dimension is called as strain. So it is denoted by letter E. So here in this image you can see that due to this force there is increase in length of this rod. So strain is nothing but the ratio of change in dimension to original dimension. Let's say that original dimension was L and change in dimension is small l. So we can say that strain is the ratio of change in dimension, that means small l, to original dimension, that is capital L. So as strain is a ratio of two similar quantity, so it has no unit. Again similarly there are three types of a strain: tensile strain, compressive strain, shear strain. Now let us see types of stress and strain in detail. So first is the tensile stress. Now what is the tensile stress? So here in this animation you can see that a body is subjected to two equal and opposite pull forces. So due to these two equal and opposite pull forces, stress is induced in that body. So that stress is nothing but tensile stress. So here in this image you can also see that the body is subjected to two equal and opposite forces. So due to which there is increase in length of that body. So let's say increase in length of that body and the cross-sectional area of that body is going to decrease. So in tensile stress there is increase in length of body and cross-sectional area will decrease. So tensile stress is nothing but sigma, which is load applied per unit cross-sectional area of that body. Now next, what is a tensile strain? Now due to this two equal and opposite pull forces, there is change in dimension of that body. Means there is increase in length of that body to the original length is nothing but the tensile strain. So what is the tensile strain? The ratio of increase in length to original length is nothing but the tensile strain. So E is equal to, let's say that change in length is delta L and original length of this rod was capital L, then what will be the strain, that is tensile strain, is equal to change in length upon original length. So this change in length is the increase in length in case of tensile strain. Now next is the compressive stress. Now what is meant by compressive stress? So in compressive stress, body is subjected to two equal opposite push forces. So due to which stress is induced in that body. So that stress is called as compressive stress. So because of these two equal and opposite push forces, there is a decrease in length of that body and increase in its cross-sectional area. Okay, so compressive stress is given by sigma is equal to, again similar, that is load applied per unit cross-sectional area of that body. Now what is the compressive strain? Now because of these two equal and opposite pull forces, so there is decrease in length of that body to original length is nothing but the compressive strain. So compressive strain is the ratio of decrease in length to original length because of these two push forces. So these are nothing but the push forces. So compressive strain is again same, decrease in length upon original length. So this is decrease in length and this is the original length. Now next is the shear stress. Now whenever a body is subjected to two equal and opposite tangential forces, then what happen? Because of these two equal and opposite tangential forces, body may shear off across the section, then the stress developed in that body is nothing but the shear stress. So here you can see there are two plates, they are connected by the rivet, and here two equal forces are applied on this plate, that is P, due to which shear stress is developed in this body, due to which the rivet may shear off across the section. Here you can see the rivet is shear off after applying the load. So that is nothing but the shear stress. So shear stress is the ratio of two equal and opposite tangential forces. So sigma is again equal to shear force upon shear area. Next is the shear strain. Now what is meant by shear strain? So because of these two equal and opposite tangential forces, the shear strain is produced in this body. So shear strain is defined as ratio of horizontal displacement to the height of the block. So in this image you can see that tangential forces are applied onto the body. So because of these tangential forces, there is displacement in the body. Bottom of this body is fixed actually. So there is displacement in this body in this way. So this displacement is nothing but shear strain. So this shear strain is equal to what? It is a ratio of horizontal displacement that is going to taking place. So what is the horizontal displacement? This AA dash is the horizontal displacement after applying the shear stress upon the height of the block. So this is the height of the block, that is AD. So which can also be equal to this displacement, that is BB dash upon the height of the block, that is BC. So this is the shear strain. So this is all about types of stress and strain. Hope you like this video. Thank you for watching.